Dear learners, welcome back to the unit 5 of hybrid electric vehicle. We will be seeing new module today, design considerations for electric vehicles. Once again, I am Dr. R. Venkatachalam, Professor, KSR College of Engineering. Welcome back once again to this topic. Today's presentation content is design requirement for electric vehicle, factors that affects electric vehicle range, types of electric vehicle configurations, then electric vehicle powertrain, specifications for internal combustion engine vehicles and the electric vehicle counterpart. So PowerPoint requirement for an EV chassis and body design, EV recharging and refueling systems, performance of EV, conclusion. It's a little bit lengthy topic. It may go up to some 20 minutes. So factors that affect EV range. So speed, wind, payload, tire traction, cold weather, HVAC, that is heat, ventilation, air conditioning, battery degradation. So when speed increases, definitely the electric energy required to drive the vehicle and obstacle the wind also very much required. The payload also defines if you increase the load, the energy required to carry the load will be higher, so the range will be reduced. Tire traction. If you climb on a hill or you always searching for or traveling in a slanted road, then the EV range will be reduced. Then cold weather also will reduce because it needs heater that will consumes the electric energy. So the power available in the battery will be used to heat or maintain the temperature in the vehicle. So that will definitely affect the range. Also heat, ventilation and air conditioning. So air conditioning also requires more power, so that will also reduce the range of the vehicle. So battery degradation. So keep on using the battery. If time increases year by year, the battery degradation will be reduced. That the depth of discharge will be reduced and state of charge also will be reduced. So this will affect the range. If you talk about range, the vehicle can travel with the available battery capacity is called range. How much distance or how much kilometer it can move from a 0% 100% charge to 0% discharge, that is called range. So performance characteristic of gasoline engine and electric motor need to be compared here. For gasoline it is given in the left side, for electric motor it is given in the right side. So torque, power, then specific fuel consumption, SFC also given. So the specific fuel consumption will be, in the beginning it will be higher, in the middle it will be low. When you keep on increasing the speed, it will be less. When you increase the power, it is reducing. If you increase the power, the torque is also reducing. If power and speed gradually increasing. So if you talk about, or if you come across motor, the motor will have constant torque increasing up to certain power and certain speed. You can say it is 1440 RPM. After that it gives stable power, and also the torque will be gradually reducing if motor power is gradually increased. Even speed increases, torque is reducing. So this is the characteristics of gasoline engine as well as electric motor performance. So we have 6 different EV configurations. That is, in this configuration is based on the clutch position, differential position, fixed gearing, then gearbox, then electric motor. Each are specified with significant letters. M defines the motor, electric motor, then GB defines the gearbox, then FG fixed gearing, D differential, C for clutch. The figure A represents the motor and clutch, then gearbox, then differential unit. So the driving is in the front wheel. Then motor, then fixed gearing, there is no clutch here, then differential unit. Here there is no clutch, there is no separate shaft. All are powered in the front wheel. Motor, then fixed gear, then differential. All are aligned in single shaft. Then the fourth case is fixed gear motor. Fixed gear motor. So two wheels have, each front wheel have different fixed gear as well as motor. That is, it is not connected with wheel, it is separated. In the fifth configuration, fixed gear is become a wheel, then motor is driving the wheel, that is fixed gear. In the sixth category, then wheel becomes motor. What the motor speed rotates, the wheel will rotate. So this is how the EV configuration, or we can say the sixth motor configuration is hub motor. So all these six configuration is possible to drive the vehicle. Now we will move to electric vehicle powertrain. So this is one of the single speed transmission EV powertrain which has two shafts S1 and S2. It's a gear pair. This is connected through S2 to differential. This is differential unit, or you can call it as final drive. So electric machine or electric motor drives the shaft, then that is S1, and with the gear pair which connects the S2 shaft, and that will drive the differential unit. This is how this powertrain functions. Then another method, it has dual clutch, that is two clutch and two speed, in order to get the different speed, two different speeds. The electric motor connected through a shaft S1 and S2. So S1 is connected to a clutch C1 and S2 connected to a clutch C2. These green points are bearings which supports the or which holds the shaft. Here the two sets of gears which is fitted to S1 as well as S2. That gear is first gear and second gear. That said third shaft S3 is fitted with three gears. First gear is engaged with S1 shaft and the second gear S2. Then the third gear is engaged with the final drive, that is differential unit. So this is how it functions. In order to obtain two different speeds, it is used. Nowadays the electric vehicles are mostly uses this, that is continuously variable transmission. Shortly we can say it as CVT, with servo electromechanical actuation system, that is servo motor 1, servo motor 2 is there. It is used to operate the driving pulley and driven pulley, or the diameter of the pulley will be varied such a way that the speed variations will take place, and the final gear which is fitted in the servo motor 2 shaft, that will drive the differential unit. So the speed different or frequent or variety of speeds can be obtained from the CVT powertrain. This is mostly used in all electric vehicles. Then EV powertrain, it is a typical model. The front wheel drive powertrain components of IC engine vehicle is shown in the left, and the electric vehicle is given in the right side. In the bottom there are two figures. First one is rear wheel drive powertrain components which is given here: engine, transmission, clutch, then rear axle shaft, differential unit and propeller shaft, and rear axle housing. It's a BMW, it's a premium car manufacturer of German. They are using rear differential unit like this. This is shown in here for your reference. So how a IC engine IC engine fitted vehicles as well as electric vehicle is specified by motor, what is the maximum power, maximum torque, type of transmission, then curb weight, then how much top speed it can run, acceleration 0 to 100 kilometer, then what is the consumption of power, then autonomy range you can say, then what is the cost. Like that it can be compared for a 2 IC engine vehicle with different capacity, and or it can be used in a urban and also with different capacity. For electric vehicle there is a one limited, and it is compared for its charges or its cost, and it can have how much cost can be spent for this different specification parameters. So power requirement for an electric vehicle. So whenever the electric vehicle is required, how much power available in the battery defines the range of the vehicle. So that also depends upon the how much weight that vehicle is carrying or how much curb weight is there. So most electric vehicles can cover up to 100 kilometers with 15 kilowatt hour battery backup. So low energy loss means that they are not very energy intensive. So while petrol or diesel engine convert a maximum of 35% of this energy into driving force, but the electric car reaches 90% and more. Here two models of cars are there. First one is Tesla Model S. It is fitted with a 85 kilowatt hour battery which can run up to 500 kilometer. The another one, BMW i3 is the variant. It can run 300 kilometer with the battery pack of 33 kilowatt hour. So weight, so your battery 540 kg. For this battery only 230 kg. So aluminum space frame 365 kg is weights, but life model is the model they are having 140 kg. So likewise the Tesla Model S in total weighs 2040 kg, but in BMW i3 it has 1300 kg. So for 33 kilowatt hour it can move up to 300 kilometer. This is 85, approximately 3 times it's supposed to move 900 kilometer per hour, but due to this weight its range is minimized. So due to less weight this range is higher. So likewise we can think or conclude. EV chassis and body design. So the EV chassis and body should be designed to meet the following points, or it should not vibrate particularly at frequencies and harmonics of rotating parts, and it should be aerodynamic. It should be resistant to impact. It should crumble evenly in an accident, minimizing forces on driver passengers. Be strong enough to fix components too easily. Be impact and roll resistant. Be aesthetically pleasing. Be corrosion proof. So these are aimed to safeguard the passenger who travels in the vehicle. So these parameter is very much important while designing the EV chassis and body design. So body design requires optimization of conflicting requirements such as cost and strength or performance and energy efficiency. There are important differences when designing electric vehicles compared to their IC equivalents. For example, extra weight is not important with an internal combustion vehicle, where a little more power can be cheaply added to compensate for a slightly heavier chassis. So savings in weight as well as increase in efficiency contribute directly to the size of the batteries, and these are both heavy and expensive. So aerodynamic track, slight weight increase in track can be similarly compensated for. So if you talk about electric vehicle, recharging is very much important. Hybrid electric vehicle means refueling also important. So there are three categories or types of charging is available: trickle charge, AC charge and DC charge. The slowest method of charging your EV at home using a standard 3-pin plug, so 220 volt plug. It is only recommended in urgent cases with caution and consultation with the electricity providers. If you are the proud owner of a hybrid car, you can fuel it like you would have fueled your old-fashioned gasoline model. So internal combustion engine along with an electric motor and battery, which means that part of the power does have to come from fuel for HEV. So performance of EV is directly affects the EV directly converts electricity into movement. So how much movement it is or it overcomes, that is the performance of EV. So for more efficient than a conventional car, an EV which has to burn fuel, create heat and then convert that heat into motion for an IC engine. For EVs, energy efficient because the advantages of over conventional vehicle, the efficiency can be transferred to from electrical energy to power to the wheel is approximately 77%. For conventional gasoline vehicles, it is ranges from 12% to 30% of the energy stored in the gasoline or energy stored in the form of gasoline or diesel. So to conclude this today's topic, effective electric vehicle design depends on the optimal integration of battery, electric motor, power electronics, lightweight materials and intelligent control systems. These design considerations enhance efficiency, driving range, safety and reliability while reducing environmental impact. Continuous technological advancements will further improve EV performance and accelerate the global transition towards sustainable mobility. So today we will conclude this lesson, then we will meet again in the another session. Thanks for your time and watching this video. Thank you.